geometry and trigonometry, new units. Today, flashback into your past. You're going to be refreshed of how to define gradients and equations of lines. Now, you probably never heard that word gradient before. You've heard a non-IB version of that word. Gradient means slope. So if they ever ask you to find the gradient of a line, that means to find the slope of the line. And of course, as Julia said, the formula, you could say y1 minus y2 over x1 minus x2. Or you can say y2 minus y1 over x2. Same thing, get the same answer, but one thing you don't want to do is you don't want to mix your positions. So if you start with y2, then you start with x2 at the bottom. You start with y1 at the top, start with x1 at the bottom. And what are those? Those are the points that are on the line. x1, y1, and x2, y2. They are the 2 points that are on the line. No, you don't have to get down and picture this graph. I'm just going to throw a little bit of TOK. You see slope in lines all the time. For example, if you put a pot of water on the stove and you turn it on to high, as time increases, the temperature of the water is going to increase in a linear fashion. Okay? So even out there in the world, you see slopes and equations of lines. Yes? Yes. Wonderful. All right, we ready to see? Blue. So, we are going to, don't write this down, we are going to find the gradients of the following sets of points. I hope and I trust that you guys can do this without me doing an example. Yes? Okay. All your examples for today's lesson are on this handout here, okay? So, you know, as we flip to examples, yes, you'll be going back and forth between your notes and the examples, but hey, I figure I'll give you a little something. So, you're finding the gradient of line L that passes through these sets of points. Give you about, like 3 minutes. Once you get all your answers, compare with your neighbor, and then we'll check it as a group. All right, do number 1 all the way out, and then follow suit for 2, 3, and 4. You should have done y2 minus y1 all over x2 minus x1, or you could do 5 minus 8 over 1 minus 2. Same thing. But you should have gotten 3 over 1, which is just 3. So our slope is 3. Did you guys get that? Wonderful. All right, Kiera, what you get for 2? 2 is a down on the left side, the second one on the left side. Negative 2. Yes? Awesome. Okay, 3. 3 is at the top on the right. Shelby, what you get? 0 over negative 3. Yes? What is that? This one's actually horizontal. So this is actually can just be 0. Okay, this is a horizontal line. All right, that's a horizontal line. Okay, and just for kicks, what would be the equation of that line?
Oh, it's just y equals b, right?
Y equals whatever the y coordinate is of the points. What is it? 6. You see, it goes to the point 2, 6 and the point negative 1, 6. No matter what, it's still going to cross the y-axis at 6. And 4, Anne Marie, what you get?
Negative 7 over 0.
And anything over 0 is what?
Linear.
It's up and down. It's undefined. You could do that, or you could actually write undefined. Does anybody do their zeros like that with a slash through it?
No.
Okay, cool. Then you can do that, or you can do undefined. And those are your up and down lines, the vertical ones. The equation is 1. There you go. Okay, you guys remember this?
Yes.
Good stuff. All right. A positive slope goes up. Negative slope goes down. There we go. Cool with gradients? All right. Well, let's get to like a real IB question, okay? So the gradient of the line, the next one now, gradient of the line passing through the points P of negative 1, 5 and QA 10, those are not in, you do have to fill them in, is 4. It says to write down an expression in terms of A for the gradient of PQ. Now when it says to write down an expression, expressions basically Like you look at an equation, like the left side or the right side of the equation. It's just like the numbers with the variable and everything. So we have to write down an expression for the gradient. So we need to figure out what is the gradient. You gotta do the equation. So it's gonna be what? Over. And 2 negatives make a what? Positive. So this can actually be simplified to be 5 over a plus 1. And that is our expression in terms of a. Simplify. A's in there. And this basically be our slope. Now part B says to find the value of a. Well, since we already know that our slope is 4, we can just set our expression equal to that. And then we just solve from here. How do we solve an equation like this? Multiply a plus 1 to the 4. Very good. And before I actually multiply, I'm going to go ahead and write it like this. So then that way you know you have to do what to the 4? Distribute. Please do not forget that you're distributing the number to a as well as 1. So that's going to be 5 equals 4a plus 4. And then you just solve. Minus 4 to get 1. Divide. And a is 1/4. Questions? Not too bad of a problem, right? Okay? Just know, gradient means slope. And if it asks you to write an expression, that basically they want you to give them an expression, basically like a formula, I guess you could say, to find your slope. And then to actually find that value, just set it equal to whatever they give you. Alright? Let's look at the next one. Alright? Says in line MN, every time that x increases by 1 unit, the y increases by 0.5 units. M is at 2.6 and n is at negative 3t. Write down the gradient of MN. If it says write down, the answer is staring you in the face. Well, that's what we're going to do in part B. It says to write the expression for the gradient of MN in terms of t. But basically, part A is asking us what is the gradient? Like, number. Close. It's 0.5 over 1. Because remember, besides the formula for slope, what's another way you could represent slope? Blank over blank. Huh? Y over x. Your rise over 1. So when it talks about your y increasing or decreasing and your x increasing or decreasing, that's what it is. It's the change of y over the change in your x. And yes, that's a triangle that needs delta for each change. So it'll be 0.5 over 1, which is just 0.5 or 1/2. That is your gradient. Okay? Now I want you guys to do A and C on your own, similar to the last example. And then we'll double check in a second. I want you to do B and C. And then we'll check. So what is my expression here? What is my expression? Peter, what you get for your expression? Well, this actually would just be our answer for B, just the expression. And then C would be when we set it equal to 0.5. But yes, you're right there on your expression, you set it equal to 0.5. And a lot of times, depending on what type of gradient you have, like say if this was a question on our test, if I see this, even though you set it equal to 0.5, so like just say you went ahead and solved for t, if I saw this, then I know you knew that this was the expression for the gradient, and I'll still give you the credit for part B. Okay. Solve this. Lee, go ahead and solve this. Careful. The t minus 6 this time, unlike the other time, is on the top. So we still need to get rid of the bottom first. By that first. So then we'll have t minus 6 equals, what's 0.5? 5 times a negative 5. Negative 2.5. So then all we have to do as our last step is to add 6, and t is 3.5.
So how come we didn't set the expression equal to what the gradient was in the last problem, but we did it in this problem?
Okay, so in the last problem, all right, in part A, it asks us to write down an expression. Now, when you put something equal to something else, you're actually creating an equation, not an expression. And so for part A, we created the expression right here by that 5 over a plus 1, and then to actually find the value, we did set it equal to that form. Okay? Creating an equation that we can solve. An expression you can't solve. You just simplify it, and that's all you can do. So when it says to create that expression, it's nothing with an equal sign. It's just, like I said, like one side of the equation. No equals. Others? All right, back to your notes. Parallel lines have the same gradients. You guys remember that? Parallel lines have the same slope. Perpendicular lines have a gradient. It's the opposite reciprocal. You guys remember doing that? You flip it and you change the sign. Well, something else that's good to know is that perpendicular lines, their product is -1. Meaning that when you take the slope and the slope of the perpendicular line, you multiply them together, you should always get -1. So that's how you can show that two lines are indeed perpendicular to each other. Okay? And just to make sure we're good on perpendicular lines, if I say that my slope is 5, what's the slope of the line perpendicular to it? -1 over 5, because you change the sign and then you flip it. 5 is the same thing as saying 5 over 1. And when I multiply them together, 5 times a -5 over 1, you get -5 over 5, which is what? -1. So they are indeed perpendicular. If I gave you a slope of -2/3, what's the slope of the line perpendicular to it? Careful. It's what? 3 over 2. Positive 3 over 2. And when you multiply them, -2 over 3 times 3 over 2, doesn't that give you -1? -6 over 6, which is negative. All right? Questions on that? So looking at a few examples dealing with perpendicular and parallel lines, we have a diagram here. And we have two lines, CA and BA. And we have to find the gradients of them. And then show that the two lines are perpendicular to each other. Okay? Well, if they give you a graph, you can go and use the formula, that's fine. Remember, time is of the essence. So we can also use the fact that, hey, slope is the same thing as rise over run. How far do we run, or how far do we rise or fall, and how far do we run to get the slope? To go from C to A, we have to go down how many? Down 1 and over 1. So my slope for CA is what? -1. And we can do the same thing for BA or AB. How far do we rise or fall, and how far do we run? We rise 2 and we run over 2. 2 over 2 is what? 1. So there's the slope of BA. That's my answer to part A. So we can also use the graph. We can go down 1 over 1, and then we can go up 2 over 2. Oh, and look what I create when I do that. What kind? Right triangles. So if you ever had to find the distance, you can always do that. Put that out there. Now we have to show that they're perpendicular. To show that, we have to see if what? If they're what? Which they are, but we gotta show, remember, when it says to show, we have to show the algebraic processes to get to the fact that they're perpendicular. Multiply them, and they should equal what? -1. That's what it says. If they are perpendicular, when you multiply the two slopes, they should equal -1. And I know it's very obvious here, but it does say to show. So we would do -1 times 1, and that does indeed equal. So yes, they are perpendicular. And everybody remembers that's the symbol for perpendicular from back in the day, right? Upside down T. What does parallel mean? What's that symbol?
Like this.
Mm-hmm. They could be the two double lines. They could be vertical or they could be slightly slanted. So that means parallel. All right? We okay? All right. Let's look at this example. Okay? And just a quick second. Okay, cool. I'll do this one with you. You do the next one. You know. Lines L1 passes through the points, those 2 points. Find an expression for the gradient of L1 in terms of A. Actually, I think you guys got this. You guys, give us a try. Remember, finding expression for the gradient is what we did, like those 2 examples with, okay? So you take your y2, subtract from your y1, and divide by your x2 over x1. So you should have gotten what for the expression? A minus 3 divided by -2. There's your expression. Then it says that L1 is perpendicular to L2. When it says perpendicular, you should be thinking, okay, my slopes are opposite reciprocals. And it says the gradient of L2 is 2. So write down the gradient of L1. What's it going to be? -1/2 because it's the opposite reciprocal of 2. So now that you have the slope for L1 and you have the expression to find A, you just set them equal to each other. Okay? One way to help yourself out is when you have a fraction equal to a fraction, you can always cross multiply to solve it. That's just one way. You can do it other ways. But if I cross multiply, what's -1 times -2? +2. That's going to equal what I get when I multiply 2 by A minus 3. 2A minus 6. Solve, I add over 6 to get 8. And A is what number? 4. You get the same thing if you solved it another way. But this is one. Questions on this? Get the next one a try. Get the next one a try. I want to time you. 3 minutes. You guys done? Go. Alright, the points are 3, 5, and 5, -8. You have 3 parts. 3 minutes. Find the gradients. Means to find the slope. Summer, what's the slope of L1? -13/2. Very good. Remember, you can do that. You get that by doing h minus 5 over 5 minus 3. Okay? Then it says a second line. I wrote it around your paper, but a second line, L2 is perpendicular to L1. Write down the gradient of L2. Don, what's the gradient of L2?
I don't know if I got it right now. I got 2 over -13.
You flipped it, but you've got to do the opposite. Oh.
That's 2 over positive.
Be positive. Yes, so you flip it and you change the sign. So since it's negative, you make it positive. And then C says to find the value of T when L2 passes through the point 50 and T over 2. So we've been doing this, guys. It would be 2 over T minus 5 equals, which one? 2 over 13 and -13/2. Because that's the equation for L2. We can cross multiply here, or we could recognize something a little easier. Exactly. Just set my denominators equal to each other, because since the tops are already taken care of and they are the exact same, set the denominators equal to each other, and you get that t equals 18. You get the same thing if you cross multiply, just do a little more work. Questions? Proceeding forward, equations of lines. Okay, this is where that good old y equals mx plus b comes in, but IV is a little bit different. Gradient intercept form is y equals mx plus c. Why c? I do not know. I'm just the messenger. That's also what's on your reference sheet. Okay, so I don't want anyone to be confused that c is the same thing that b was, the y-intercept. Okay, c is the y-intercept. M is your gradient, of course, and that is pretty much the main way they're probably going to ask you to write an equation of a line. Okay. However, good old point slope. Some of you guys learned how to write equations of lines using point slope formula. So I wrote that down there just as to refresh your memory. And honestly, you can get to slope intercept form through point slope by just doing a little bit of math. So it's really to each his own, whichever way you prefer. So look at this example. It says line L passes through the point A, 1 to 7. It has a gradient of 5. Find the equation of L and give your answer in the form of y equals mx plus c. Now I'm going to do both ways. And after I do both ways for this one, you choose whichever way you feel more comfortable doing. Okay? Because some people learn how to write equations of lines using point slope. Okay? And honestly, point slope, hey, if they give you a point and they give you the slope, why not start out with that? Okay? So we have our point. We're going to plug that into x1 and y1. So we'll have y minus 7 and then x minus 1. And then we're going to plug in our slope, our gradient, which is 5. Now because we have to write it into slope-intercept form or gradient-intercept form, we're going to have to do a little bit of math. We're going to distribute over the 5 to get 5x minus 5. And then we add 7 to get y by itself. That is gradient-intercept form. So my answer for this problem is 5x plus 2. That is the equation of my line. You guys remember this? But some of you guys learned using straight the slope-intercept form. Okay? The one thing you don't know by giving a point and a slope is your y-intercept. But you can find it by using the point, plugging that in for x and y, and using the gradient and plugging that in for m. So I'm going to plug in 7 for y, 5 for my m, and 1 for my x to solve for c. C is the one thing that I don't know. But I can find it. Multiply to get 5 plus c, subtract 5 from both sides, and c equals 2. So now that I have my y-intercept, and I have my slope, my equation is a cinch to write. So no matter which way you do, we should still end up with the same answer. It really is more what is your preference on how you write your lines. Okay? So here are 2 ways for you to do it. So you choose. Okay? You choose. You just tell me if, if we come to a homework situation, you're like, hey, I didn't get this one involved in equations of lines, I'm going to ask you, which way did you try to do it? You say point slope, hey, I do it point slope. Okay? But no matter what, we should end up with the same answer. And honestly, it's about the same amount of work. Same amount. Here we go. This one's on you. You're on your own for this one. At least do A and B. And then I'll chime in and C and D, okay? So in about 2 minutes, I'm going to chime in and then we'll finish up the problem. So the equation of my line has to be in the form of y equals mx plus c. Which way did you guys figure it out? Using, wait, raise your hand, do you use point slope? The one that we had to distribute. Alright, and then if you used slope intercept? more people went the other route, I'll go that route. So, using point slope, I plug in my 2 and my -1 for x1 and y1, so that's going to be y plus 1. It needs to be a plus because the minus and the negative make a positive. M would have been 1/3 x minus 2. I have to distribute that 1/3 over to get 1/3 x minus 2/3. Last thing we have to do, subtract 1. You have the luxury of using your calculator, so you would have been able to convert whatever that was back into a fraction. It would have been for your better interest. And you would have had y equals 1/3 x minus 5/3. If you said 1 2/3, that also would be acceptable. Now it says to write down the point of intersection of L with the y-axis. It's basically asking you, what is the y-intercept? What is that point? Remember, in this form, the y-intercept is which variable? C. So C over here is a -5/3, so we write that as a point. Does that -5/3 go in for my x value or my y value? Your y value. What is your x value when you have a y-intercept? Say it. 0. So there it is. It's a -5/3. 0, -5/3. You can also find it out. Say you forget that piece of information, just plug in 0 for x and solve. You'll be able to find your y-intercept. To find the points where it intersects your x-axis, i.e. your x-intercept, you do the opposite. You plug 0 into y. Solve for x. So I'm going to do that down here. 0 equals 1/3 x minus 5/3. I have to solve for x. How do I do that? Plus 5/3. And then I can divide by 1/3 or multiply by the reciprocal. Okay? You can divide by 1/3 or multiply by your reciprocal. And the one thing that scares me about you guys dividing by a fraction is you not putting in your parentheses and getting the wrong number. But you can always multiply by the reciprocal because it will end up canceling everything out. And look here. The 3's cancel out as well, and you're just left with 5/1. So it's just 5. Huh? And it would be 5, 0. So those are my 2 points. I have a y-intercept of 0, -5/3, which is in between, and an x-intercept of 5, 0. So to draw my line, all I need is 2 points, and there you go. Draw a nice straight line connecting those two. And there you go. The equation of a line can also be written in one last way. You have gradient intercept form, you have point slope form, and then you have this form of ax plus by, and I'm going to go ahead and change this to a plus d equals 0, where a, b, and d symbol. Those symbols should look familiar. What does that mean? And what are integers? Negative and positive whole numbers. So this form right here of ax plus by plus d, which is called standard form, is another way to write the equation of a line. And a, b, and d are all positive or negative whole numbers. No fractions, no decimals. Okay? So if you ever had to write something in standard form, you want to make sure that you have no fractions and no decimals. Right? Now when you look at this form, this d is the same thing that c was in gradient intercept form. It is your y-intercept. Why it's D, don't know. I'm just the messenger. Okay? And that's also what they use in your reference booklet. And I don't want you to be confused when you look at it like, well, what's D? I thought it was going to be C. It's D. It's still the y-intercept, okay? So whatever that number is, that's your y-intercept. All right, so let's look at an example. We have an equation, 2x minus y plus 6 equals 0. And we have to write down the gradient of this line. We have to write it down. Now, it might be a little hard to see the gradient in this form. What's the easiest form to see the slope in? Mx plus c. So how can I rewrite that into that form? How do I get into slope-intercept form? What do I have to do? You gotta move some stuff around. And when I move stuff around, what do I have to make sure I do? Gotta get the y by itself. How do I get y by itself here? The easiest way probably just to add y since it is by itself. So if I add y over, there's my equation to slope-intercept form. And I can easily see that my gradient is what? 2. Remember, it's in the form of mx plus c. So my gradient is 2. What's my y-intercept? 0.06. Questions up to here? Now it says point A lies on the line. And we have to find C. Well, this is it's not too challenging. If that's a point on the line, then that basically means that I can plug that in for X, and I can plug in this for Y to solve for C. Okay? So I have a whole bunch of points that make up this line, and if this happens to be on that line, then to solve this, to figure out C, we just plug in C for X and 1.5 for Y. Because it should equal if there's a point on the line. So subtract 6. What's 1.5 minus 6? Negative 4.5. And then divide by 2, and C is negative 2.25. So that's the point for A, negative 2.25 and 1.5. B is a point on the line. Find T. I'll give you 1 minute to find T. What's T? 16. You do the same thing. You plug in 5 this time for X and T for Y, and you see that you'll have 10 plus 6, which is 16. But using your lines can tell you, your line can tell you a lot of things. It does, not only tells you your slope, but it tells you your y-intercept. It also can help you prove, verify, or deny whether or not points actually lie on that line. Okay? You always just plug it in for X and Y and see if the left side equals the right side. If it doesn't, then it's not a point on the line. Now it says that L2 is parallel to L1. So what is the gradient of L2? 2. And remember, parallel lines have what types of slopes? The same. F says to find the equation of L2 if it passes through this point of 0, 4. Find out what that equation is for L2. What is the equation for L2? That point was the y-intercept. And in that form of y equals mx plus c, all you need is your y-intercept if you already know your slope, which was 4. So y equals 2x plus 4. Think smarter, not harder. Okay? There you go. I mean, yeah, ahead and do point slope, distribute, whatever. But save some time to be able to recognize. Okay? L1 joins the points A and B. Find the equation of L1. Now this one's different than any of the ones that we've done before. Why? We don't have the slope, nor the y-intercept. We were just given 2 points. So we're actually going to have to take everything that we've done up to this point to figure out the equation of the line. We know how to find the slope. You guys did that with no issue at the very beginning. That was like the first 4 examples. You guys found the slope. Find the slope right now. What's the slope? -2. -2. Remember, y2 minus y1, x2 minus x1, 4 over -2. Your slope is -2. Now, to actually find my y-intercept, we have 2 points here, unlike before. We only need one of those points to create my equation, using whichever way you prefer. So decide, are you going to use A or are you going to use B to write the equation into slope-intercept form? All right, if you want to use A, okay. Use A. Take that point, take that slope, and write the equation like you did a few problems ago. Give you a minute. So if I use point slope form to get this done, it'll be y minus 2 equals -2 x minus 1. Distribute over the -2 to get -2x plus 2, and then you had to add 2. So your equation was y equals -2x plus 4. You got that? Good. So the points A and B make up the line to create this equation. Now part C says decide whether part B says decide whether A, B, and C are collinear, giving a reason for your answer. And a lot of times when it asks you to justify your answer, you can actually write that out in words, but sometimes the mathematical processes to answer the question will suffice. If C is a point on the line, that's what collinear means. That means when I plug in 10 for x and -16 for y, I should have an equal equation, if they are indeed collinear. Because then that basically means that when I'm looking at this, I have A, I have B, and I also have C along this line. And actually go the other way to the negative stuff. But you get my drift, right? So let's see. I'm gonna plug in -16 for y, 10 for x, and I'm gonna see if the left side equals the right side. -16 equals, what's -2 times 10? And what's -20 plus 4? -16. Since the left side equals the right side, this basically tells me that yes, they are collinear. Because if 10 -16 was not a point on the line, then that means that these two equations wouldn't be equal to each other. It would have been like -16 equals like 12 or something like that. Okay? But yes, the work right here will justify the reasoning behind why you say that it's a yes. Okay? Alright. Last 2 slides and notes, I won't be able to get to the last 2 examples. But kind of already talked about this. Remember, your vertical lines are x equals a number, and y, and horizontal lines are y equals a number. Okay, k just represents a constant. And the last little bit talks about the different types of lines that you can have. It's a little bit of a lot, so that'll be the last thing that we do. All right. If 2 lines are parallel, then they have the same gradient, of course, and they do not intersect each other. But that can happen in 2 different scenarios. The first one over here is when you have coinciding lines. This basically means that once you simplify everything, the equation for one line equals the equation for the other. So 2 lines with the exact same equation, the exact same slope, the exact same y-intercept. Or you can have just 2 parallel lines. In this case, they have the same slope, but what's different? Say it again. The y-intercept is different. Okay? Now, two lines are not parallel, then they intersect at exactly one point. Now, these lines, they don't necessarily have to be perpendicular, but if they're not parallel, then they're going to intersect at some point. Okay? They are going to intersect at some point. Now, in order to figure out that point, all you need to do is set the two equations equal to each other and solve. Okay? And it's pretty straightforward since they're both in slope-intercept form. In this case, you would just set them equal to each other and solve for x. How do you do this?
You need to get x to one side.
And to do that, I would what? Add x. So 3x plus x is
4x.
4x, and then, say again,
Add 5.
add 5 to get what?
4.
4, and then,
X equals 1.
so that is the x coordinate of where they intersect, and I know it's easy to see, maybe not with the background, but to find the y coordinate, all you do is pick one of the equations and plug in. All right? 3 times 1 minus 5. What is that?
-2.
So where they intersect is 1, -2. That's how you would do it algebraically. And that will wrap up, because the next example was just to show finding where two lines intersected without the graph. And then just a general one to sum everything up.